Hi all and welcome back. So this is the final exercise that we have on our lesson on truncated cylinders. So the shape of the object that we're looking at here is an electric car charger that I saw a couple of years ago when I was on holidays. And you can see basically what we have here is we have two cylinders that are separated by a kind of a rectangular portion in the middle. So really, if you can imagine, let's look here at the base here. You have a semicircle there like that. Then you have this rectangular bit in the middle, and then you have another semicircle. So that is extruded or brought up like that, and then sliced here like so, and then cut here kind of in half in our kind of in from the side like so. So it gives this kind of unusual enough kind of shape, but yet at the same time, um, because it's based on regular solids, it's actually quite easy to create in real life. So let's have a look at our question as we kind of typically do. Looking in from the direction of A is our front elevation, B is going to be our plan, and this time C is looking in from the right hand side. So if C is looking in from the right hand side, then our end view is going to be on the left hand side. Um, Going back to our ideas of our profiles, well, we have our main body of our object here, which is going to be this kind of two semicircles like that with a rectangle, and that's going to be seen looking in the direction of arrow B. So there's a lot going on maybe with this one, more so than some of the other questions. So, and that's really just to hide which or where your profiles are. So you really have to be able to kind of look at the object and say, okay, well, where this front is curved, this back is curved, where do I have to look to see that that's curved? And the answer is from above. Um, then we have our second interaction, which are these slices. So our slice in the front here and our slice here along the side, like so. So that's going to be seen when we look in the direction of arrow C here for our end view, like so. So let's set it up on our sheet. You can see here is our plan. So A and B is our elevation and plan, and our end view here is going to be to the left hand side, because remember we're looking from the right, so it's going to appear on the left. Here is our 3D setup as he is there, and we're going to draw in our profile views first. So the main profile view is going to be our, I suppose, our shape of our object as seen from above. So I'm going to draw in my center like that. That's going to be my the back of my object, and then we're going to come down. That's going to be the rectangular bit in the middle, draw a line across, and then we're going to draw in the front of our object, like so. You can see our front of our object here is looking in straight in at it. So our plan is directly from above. So this is going to be at the back. This is going to be at the front of it. So there is the back, circle at the back. There's the circle at the front. The next view we're going to draw in is going to be our end view, because that's where we're going to see our straight cut here as our straight cut. So there's our, don't forget our hidden line there just for this little edge here like that. So to draw in our end view, we're going to draw in our YY line like so, so our side wall, our 45-degree line like so, and as before, I'm going to just draw a line through the center like that to locate the very back and the very front points. So I'm going to take my front point across and up to locate the front here. Same with the back point across and up. And I'm going to just looking at my question, you can see we have our height here up 70 mil. We have an overall height here of 150 millimeters, and it's sloping down a total of 40 mil here. So from the highest point down to the lowest point here is going to be 40 mil. And these little symbols here, if you haven't done drawn before, indicate that this slope of this underside here is the same slope. So what we do here is we draw in the top like that. So that's our top point, and we draw in our, connect him down to our drop of 45, and then using our siding set squares. So you get one set square like this. We had seen this in our very first lesson. So I'd say our 45. You can get your 30-degree set square like that, and you don't have it on our t-square. We just offer it up. So we're holding this guy firm against this, making sure that this guy is keeping this angle, and then with your hand on this set square, so that this guy is fixed to the table, we're able to slide this guy along and then down to our point here where we'll transfer that, making sure that the top and the bottom surfaces here are parallel. So that is our side profile. And again, if you go right back to the very first worked example, you can see the slice here and the slice here, Whether the front here is curved or the back here is curved, it doesn't make any difference. That's still a straight slice. That's still a straight slice there. Profiles don't affect each other where in your profile views. So same thing applies. Whether this top here has been sliced has no effect on this being seen as a semicircle. Only in our combined view do our actual profiles get distorted or changed. So once we have that done, well, what we can do is we can kind of tackle it the same way we approach a lot of other questions. We can, using our 60-30 on our center point here, break up the bottom curve into our 7 equal parts. And we can do the same then with the top using our 60-30 set square on our center point. And you can see I've labeled them 1 through to 7, and I've just marked them with a red dot here. Here I'm marking them with a green dot, just so that I know which ones are the top ones and which ones are the bottom ones. So what we're going to do is we're going to take each of our points across and locate them on our sloped profile here. So 1 through all the way to 7. Same thing applies with my my green ones. I can take them across and up. For the moment, I'm just going to bring them all up into my elevation, so my combined view, and I can take them across. So let's work the bottom curve first. 4 joins up with 4 here. 3 and 5 are going to go across and cross with 3 and 5 there. 6 and 2, and then 7 and 1. And that gives me my elliptical shape here along the front of my piece. So then we repeat the process here for the back, again labeling them up and then bringing them across like that. 4, 5 and 3, 2 and 6, and 1 and 7. And that gives us our front and our back curves like that. And you can see there's the width of our piece like that. And how far does that go up? Well, it goes up as far as 7, and from 7 then it starts to curl in. Some people will draw that up to the overall height. Remember, the highest point is this point here. The actual sides of it are going to be slightly lower like that, just where it starts to curve from our straight section there like that. So that's the end of our straight section there, and that's where it starts to curl in to our highest point up at the top. So that's our top surface completed there. And you can see when you actually break it down, it's very, very similar to our previous exercises. You have your circle broken up and you have your straight cut there. Find your points on your circle, find them on the straight cut, and then bring them together. So only for the fact that it's our cylinder has been basically separated, it's exactly the same. Now what we want to do is we want to do the same for our kind of bottom surface here, which is going to appear as a hidden line because it's behind the object. But the same basic approach applies. You can see the actual top surface that we have here and this undersurface here like that, they're actually identical. So they are the same curve. And if we look at it in our plan view, the point 7 could be 7 for the top surface. He could also be 7 for the bottom surface. One is stacked directly on top of the other one. So there would be like say number 1 here. There's where 1 will be on the top surface. There's where 1 will be on the bottom surface. So your green points here will count for our top surface and our bottom surface here. What's missing or what's different is that, well, there they are on our top surface here. We need to locate them on our bottom or under surface here like so. So we can take our corner point, just take them across. That's our edge there like that. And we can take our points there. So you can see there's 1 and 7 on the bottom, 2 and 6 on the bottom. And I'm just going to take them straight across. So that's each of the points taken across, giving me my hidden curve underneath the piece there like that. And there's my end view then, sorry, my front elevation completed like so. So that is my overall piece then completed. For anyone who has done drawing before, there is another method that you can use to get this bottom curve here. Because this bottom curve is actually identical to the top curve here, if I just go back one step there, what you can do is you can just find a single point. So if I take 4 here and 4 here, if I just take 4 across, well, if I know, I can find him very easy. So I know the difference between the top and the bottom curve. All I need to do is just take each of these points and move it down the same distance. So if I set that distance, so from 4 to 4 here with my compass, let's just for argument's sake say it's 100 millimeters. Actually, sure, we can even look and see what it is. It's so 70 and 50, so it's going to be 80 mil. So that distance there, so the distance from the top point here to the bottom point here is going to be 80 millimeters. That means that every point on our top curve here is going to be 80 mil above the bottom one there. So if you set your compass, that distance there are 80 mil, You draw your line straight down from 3 and just strike an arc down 80 mil. Now you found 3 on the undersurface. Same thing applies. You can put the point of your compass there, strike your arc there. Now you found 2. Now you found 1. So it's a nice quick way to kind of copy a curve just directly below. So it's what's known as a translation. And it's just a quick way to kind of copy a curve that you already have. Not that taking them across here is that difficult or anything like that. Just it's one little bit less construction. But that is our exercise completed anyway, completed with our hidden detail. You can see the exercise here definitely was a little bit more kind of abstract compared to some of the other ones, but the principles are the same. The approach that we do is the same, and the way we look at the question is exactly the same. So, once you can get a handle of that, it really means you can apply it to so many different scenarios, and that's the whole point of what we're doing, really. Okay, so hopefully now through the videos here, you've been able to kind of follow along. If you do have any questions, you can always ask me and ask the next day. Aside from that, guys, best of luck.